In this video, I would like to show some basic ideas about circuits, and I've set it up on my desk with the camera over my shoulder. I couldn't find an easy way to do a whiteboard at home, so I have a very low-tech whiteboard, and I made some little red marks on the table just to remind me where the frame is on the camera over my shoulder. I want to start with just some review from grade 9 science, and I know maybe some of you have not done this semester in grade 9 science, but I'm taking a chance. You've done some review like I asked, so I just want to build on it, give it a bit of a real life context. The first idea is a series circuit, and I just want to build some vocabulary in your head. Pretty much any circuit has to have 4 parts, and I'm going to start with a drawing, and it probably looks familiar to drawings you've seen somewhere on the internet, in your textbooks, in your class notes, I don't know where, but this drawing looks very theoretical and it's relatively easy to get, I think. So, what are the 4 parts? Well, any circuit, any electrical circuit pretty much has to have these 4 parts. If you don't have these 4, you got problems. You probably don't have an electrical circuit. The first one is right here, and this is the power supply. Okay, so often scientists and stuff like to use very theoretical words or something. They call it the power source, the power supply. It could be a few things: a battery, it could be a solar panel, it could be plugged into the wall in some control. Somewhere you have to put power in. They draw this symbol, short line and a long line, and it typically means some kind of a battery. The long line is the positive side and the short line is the negative side. So I always remember the short one is like a little negative sign, and that reminds me that's the negative side. A lot of people think the electrons in a power supply and a battery come out the positive. In fact, the electrons flow out of the negative. We back into chemistry somewhere, you know electrons have a negative charge. And negatives repel negatives, so they get pushed away. They repel each other. Coming this way, the electrons come back through and they're attracted to the positive. Positive attracts negative and gets sucked back into the power supply. So just a bit of a different way of thinking. So we have a power supply. Now, the next big part of any circuit are these things. And most people just call it a wire. But science people always have to have a hard word. A conductor. Something that conducts electricity. Okay? And oops, I'm writing over where I didn't want to write, but it's the wire. Then up here they have something often called the control. Okay? Again, very scientific, very technical, but we all just call it the switch. So we need a source of energy, we need wires or conductors to carry that energy and the electrons wherever we want to go. Almost always in a circuit you have something to control it, turn it on, turn it off, or whatever it is we want to do. And then over here, you wouldn't have a circuit if you weren't trying to do something. Run a flashlight, make a cell phone, do something. And so it's called the load. And I think in classrooms and stuff, typically in circuits that I've seen in classrooms, the load they use are light bulbs. Because it's easy, you can see it work. And I'm going to show one in a minute, but there's an example of a light bulb, different examples. So 4 main parts: power supply, wires, conductors, some kind of a switch, and some kind of a load. And when these are all hooked together, you have a circuit. Why is it called a series circuit? Well, everything goes in a series, one after another, all in line. So I could technically have another load here, another light bulb, another source, something that's taking energy away, and I could have another one here in my circuit, but each one of them goes in line. It's one after another, series circuit. So in any series circuit, the electrons all go the same path through all the different loads, same way, around and around and around. On the power supply, you sometimes see things drawn like this. And what they're really saying is each pair of short, long, short, long, short, long is one battery. So if you take a typical battery like this, you'll notice that it's really marked positive and negative. And most of you maybe have known that that little raised dimple part and then the flat part on the bottom is the negative. So when you use batteries, you always have a positive and a negative. So when you draw something like that, you're really saying is I have multiple batteries. And I have this light from my bicycle. You've probably seen this many times. Positive to negative to positive to negative to positive to negative. What you're really doing is you're making a power supply that adds up the different voltages from the batteries. So you've probably seen this mistake. If you put it in this way, it won't work because you put the battery in the wrong way. Okay, so when you see a drawing with something like that, that's all that really means. The conductors are really just wires. And I had this old phone that I couldn't use, it broke or stopped working or something. And I just wanted to show something familiar, if this camera will focus. Where are the wires here? And some of you probably have seen circuit boards and stuff. You can see really close, I'll try to zoom it in here. You see these little paths along, those little sort of gold or green lines that go along the circuit board. Those are the wires. Those are the conductors. Those are the little paths where the electricity flows. So it doesn't have to be a wire, say, like something like this or something, where you know it's pretty clear what the wire is. The wire can be something else. Another thing, sometimes the switch isn't as obvious. Underneath this phone pad there was these touch buttons, but really underneath, if you look closely, there's all these little switches, and each one of these switches is connected through on the circuit board, and that's how that part of the circuit works for a phone. Probably a little more familiar, you've seen a switch like this somewhere in your life, I'm guessing. And somewhere hiding and behind, you don't see it, but there are connections where they put the wires on. And again, electricity will come through on one side, and when you flick the switch, somewhere inside something closes, and the electricity can the electrons can flow through that connection. So that's another example of a simple series switch. The trouble is, often in school, you get these pictures and you think, oh, okay, that's very easy. I can do that. It seems so obvious how to make a simple circuit. Then someone comes down and says, here, make a circuit. And students kind of stop and like, huh? But really, it's not that hard. I found this 12-volt battery lying around for something I have. That's my power supply. These are my conductors, my wires. This is my load, and I'm going to make a very simple switch. I'll just touch this to one side on the battery, on the battery, positive, negative, you just have to connect through, and there's the load. There's the resistor. That's the part that takes the energy out. So when I touch it, if I can do this without shocking myself, then the light works. There's my switch. Off, on, off, on. Okay, it's a bit of a cheesy switch, but it is a switch. So when you're looking at circuits, you're always thinking, what's my load and what's it really doing? In this case, my load was a simple light bulb, and it's taking energy out of the circuit. But in any series circuit, or pretty much any circuit, the power source is the device that puts the energy into the electrons. And it usually does that with some kind of a voltage. The voltage is the push. The voltage pushes the electrons, gives them energy. If you watch the video I linked on the Google Classroom site, you'll see the idea that The power supply pumps up the electrons, gives them energy. Then the electrons come through the circuit. They have a lot of energy, and they want to get rid of that energy. That's what the loads are for. Whether it's a light bulb or some kind of an LED flashlight, it could be a toaster, it could be a hair dryer, a microwave, a refrigerator, it doesn't matter. The load needs to take the energy out. That's what the load does. Now, the energy could come out in different forms. In this case, the light bulb gave off two forms of common energy. One form is light energy, so you could see that. And some of you have probably known this, you don't realize it, but one of the things about these light bulbs is they give off a lot of heat energy. That's why they're very inefficient. And that's why a lot of the world is switching to LED lights now. LED lights give off light energy, but they don't get hot. They don't use nearly as much energy because they don't give off all that heat energy. But the loads are always there to take energy away. The power supply put energy in. Electrons get charged up, go through the wires, give off their energy, come back with low energy, juice it back up, and come back and around. So the voltage is that push, that amount of energy you're pushing in. The more voltage you have, or the bigger the battery or whatever, the amount of electrons going through is called the current. And the current is really just the amount of flow, how many electrons are flowing through. And again, if you watch the video, I hope that makes sense, that the current just shows how much energy, how much electrons, how many electrons are flowing through the circuit. That's what the current is. The load is often measured in something called resistance. And this is why they draw it with this wiggly line. Everything's nice and smooth, straight road, and then all of a sudden you get this bumpy, windy, wiggly road. It makes it hard to go through. There's resistance there. So the resistance in the load makes it lose energy, gives off the energy. If you look at a light bulb really closely, I don't know if you've ever zoomed in, really that little wire is very, very thin. And the idea is push the current through. When it hits that very thin wire, it's hard for the electrons to go through the wire. There's a lot of resistance. So the electrons kind of say, keep up the energy here, get rid of it. And they dump the energy off in light and heat. And when they come back down, they're at a very low energy state, and they go back into the power supply and get more energy. So the resistance really is a measure of how much it'll suck the energy out, how hard it is for the electrons to get through the circuit. Now, to switch gears a little bit, it's kind of the same idea, but I'll just recap and finish the video. The second kind of circuit you've seen in science class, etc., is called a parallel circuit. It has all the same parts as a series circuit. Something here, you may or may not have a switch somewhere to control it. I could have had a switch here, which controls everything, so the electrons come through here. If that switch closed, everything downstream gets electricity. If that switch is open, nothing gets electricity. But the difference with a parallel circuit is, as the electrons come down this wire, now they have a choice where they're going to go. Some of them can come down this branch, some of them could come down this branch, some of them could come down this branch. This load, or this resistor, or this load, depending what you call it, each one of them will suck off some of the energy. I think it's not hard to imagine if this resistance was very, very high, the electrons would come along here and kind of get backed up here and say, oh, that's too hard to get through there. There's too much room. Let's go this way. Or let's go this way. So you can imagine there's a certain amount of current going through each of the branches on a parallel circuit. Which branch would have the most current? Which branch would have the most electrons going through it? the one that has the least resistance. So it's kind of this inverse relationship. You have a lot of resistance here, electrons will skip that branch and go somewhere else. Too hard, too hard. Kind of like teenagers going places. Where's the easiest path? That's the one I'm going to take. So if you have different resistances, the current is inverse to the resistance. A lot of resistance, not much current. No resistance, let's go that way, lots of current. If each of the three loads had equal resistance, you can guess what current's going to be in each branch. It would be equal current. So parallel circuits aren't really different too much from a series circuit, except in a series circuit the electrons have to go through everything because you have no choice. There's only one path. Whereas a parallel circuit, it can go through multiple paths. Why are we doing all this? Well, I want to teach you in the next video how to make simple circuits, real life simple circuits that we can transfer to TinkerCAD and use to build up our understanding of electronics. So I give you the background on simple circuits because I need it for this stuff. I hope the video works.